Hello, my name is Phil Cayton, and I'm a senior staff engineer in the Software and Advanced Technology Group of Intel. I also serve as co-chair of the NVM Express Boot Task Group. Today, I'll be introducing the new NVM Express Boot Specification. The goal of developing the NVMe Boot Specification is to expand the NVMe family of specifications to include standardized, transport-agnostic booting from local and remote NVMe namespaces. It defines constructs and guidelines for booting from NVMe namespaces over NVMe-supported transports. The NVMe boot specification includes material that describes general concepts for NVMe boot and mechanics such as ACPI tables to enable pre-operating system and operating system environments to share configuration context. It also introduces an annex, which contains an overview of boot stages and flow in a UEFI pre-operating system environment, as well as other best practices for reliable operating system consumption of pre-boot configuration information. Since NVMe technology is already in widespread use for booting over the PCIe transport, the initial version of the NVMe boot specification defines extensions to the NVMe interface for booting NVMe over remote fabrics and particularly concentrates on booting over the TCP transport. TCP/IP is fundamental to many data centers, and it's well understood. NVMe over TCP allows users to run NVMe over fabrics in data centers just by enabling it. Thus, standardizing booting over NVMe over TCP was deemed a great starting point for the NVMe boot specification to support existing infrastructures. And in order to speed the development and standardization of booting over NVMe over TCP, we leveraged the groundwork of booting over iSCSI, including adopting a similar boot flow handover mechanism as used by iSCSI. iSCSI used an ACPI iSCSI boot flow handover mechanism called the iSCSI Boot Firmware Table, or IBFT, as its mechanism to share pre-operating system configuration with the operating system. The NVMe Boot Task Group developed a similar mechanism called the NVMe Boot Firmware Table, or NBFT. Among other things, the NBFT contains host fabric interface descriptors, which defined networking details for each of the fabrics on the host. The NBFT also has a list of target and storage subsystem details and route relevant information for each subsystem configured or discovered. The NVM Express Consortium developed the NVMe boot specification in collaboration with ecosystem and industry partners, including the UEFI forum that helped add the ACPI NVMe boot firmware table and the UEFI system specification. It included DMTF, that helped add standardization for the Redfish NVMe over Fabrics secrets registry to facilitate exchange of secrets and credentials for common NVMe over Fabrics connections that's utilized by both the pre-operating system environment and the operating system. And it included an open source public reference implementation that consists of both pre-operating system and operating system runtime software based on the UEFI EDK2 and the NVMe boot specification. And this was developed to aid developers from across the industry. The NVMe boot specification is a living document, and moving forward, it may be amended to define booting over additional NVMe-supported transports. Additionally, the annex may be enhanced with material focused on further improving ecosystem interoperability. The NVMe boot specification benefits many markets. More than data centers, it also benefits HPC, edge, and cloud infrastructure markets that use multiple operating systems and operating system configurations with multiple diverse data sets. Additionally, the specification offers enhancements in terms of both performance and security for hyperscalers and enterprise organizations. It offers building of composable disaggregated servers with less actual physical storage. It offers reduction in the number of boot images resident on a given server. And finally, it offers quick recovery of systems following natural or unexpected disaster. A few notable use cases for the NVMe boot specification include booting cloud servers from a particular system with specific software and development features, and booting over remote storage and providing access to non-boot data namespaces with application data stores that are available upon system boot. NVM Express members can support the NVMe boot specification development in a few ways. The NVM Express Boot Specification Task Group meets weekly to discuss the development and additions to the NVMe boot specification. There are currently over 100 members from 36 member companies involved in the NVMe Boot Specification Task Group. If you or your company is an NVM Express contributing member that's interested in getting involved, then join the task group. Members of the task group get to review technical proposals and help develop the latest features. There are multiple ways to learn more about the NVMe Boot Specification. The co-chairs of the NVMe Boot Task Group have recorded several in-depth presentations and Bright Talk webinars that go into further details about the development of the NVMe Boot Specification and the reference implementations. These presentations cover the phases of the boot process in a UEFI environment, the structure of the NVMe Boot firmware table, and tools that were developed to support booting over NVMe over fabrics. You can view these presentations and webinars on the NVM Express website under the Education tab. The NVMe Boot Specification is available on the nvmexpress.org website on the Specifications page, along with the entire family of NVMe specifications. Additionally, an open source reference implementation for booting over NVMe over TCP architecture is available on both OpenSUSE and Fedora distributions. For a deeper dive into the specification, read the NVMe Boot Task Group's blog covering the boot specification that's available on the NVM Express website blog page.